Okay, now we're going to learn to match graphs with a rational function. So in this example, I'm starting with with function g. So I have to find which one of these 6 graphs is the corresponding graph for function g. To do that, you have to find the 4 basic parameters: vertical asymptote, horizontal asymptote, and y and x intercept. So remember, it's always easier to identify things when you factorize both the numerator and the denominator of your original function. So in this case, here I have my factorized form. Y, I factorize a 3 in the numerator, and then two numbers that multiplied give me -6 and added give me +1. Those values are 3 and -2. Thus, if I grab the denominator, the invalid values are vertical asymptotes because none of them are common factors with the numerator, meaning we don't have holes. So both of them are vertical asymptotes. Then, because the degree of the numerator is smaller than the degree of the denominator, that means that my horizontal asymptote should be y equals 0. Then, to find the x-intercept, remember what you have to do is to graph the numerator and solve for x. So this is the numerator. So finding the zeros of this denominator means equating to 0 and solving for x. So means that x has to be -1. Lastly, to find the y-intercept, what you have to do is evaluate your function in 0. So if I evaluate my factorized function, because it's easier in 0, this would mean this would be 3 times 1 over 3 times -2. This gives us 3 over -6, so that is -1/2. So let's identify which functions satisfy this. So vertical asymptotes in -3 and 2. This cannot be it. This one has a different vertical asymptote, and this one has a different vertical asymptote. So we are left with these 3. The three of them have the horizontal asymptote in y equals 0. Now let's check the x-intercept. The x-intercept should be in x equals -1. So this one could be it. This one obviously is not because it has an x-intercept in 3. And this one can also possibly be. Now, the y-intercept. Notice that the y-intercept for this function is y equals -1. This one has a y-intercept in +1, so this one cannot be. So lastly, this function does have the y-intercept in -1/2, so the appropriate answer would be graph E. Let's do the same procedure with function h. So, first of all, let's factorize the function. My numerator is a constant polynomial, and my denominator is two numbers that multiplied give me -12 and added -1. So this is x minus 4 times x plus 3. So the vertical asymptotes, because my denominator does not have any common factor with the numerator, it means both of these factors or invalid values are vertical asymptotes. So one vertical asymptote is in x equals 4 and the other one is in x equals -3. Now, for the horizontal asymptote, notice again that both my numerator and my denominator have different degrees. So the degree of the numerator is 0, the denominator is 2, so the horizontal asymptote should be y equals 0. Then my x-intercept is the zeros from my numerator. Because my numerator is a constant polynomial, that means that we do not have x-intercepts. And lastly, the y-intercept is found by evaluating the function in 0. So if I evaluate the function in 0, this is 4 over -4 over 3. This is 4 over 4. This is -1/3. So let's start identifying which graphs are valid. Because the vertical asymptotes should be in 4 and -3. This function, this graph, and this graph are invalid. It can only be A, B, or D. Now, The horizontal asymptote is in y equals 0, meaning graph B cannot be because it has an horizontal asymptote in 3. Now, it doesn't have an x-intercept, okay? Both of them don't have an x-intercept. And lastly, let's check the y-intercept. The y-intercept is in positive minus 1/3, meaning that graph A cannot be because its y-intercept is positive. So my correct answer is D. And that's how you match graphs with rational functions.